showing 3 millimeters off center line. Adjusting now.
Copy that, visually aligned.
The yield strength is confirmed, right within the parameters.
Noted. The batch meets specifications.
Divergence successful. Ensure the process B count is updated on the manifest.
Done. All parameters within spec. Process A pre-machined ribs selected.
Quantity and consistency lock verified. Send to assembly.
Check this tolerance against the manifest, section 4.
Looks good. The digital overlay matches the physical component. The alignment on bulkhead 7 looks slightly off tolerance.
It's within the acceptable margin, but let's double check the sensor calibration before welding.
This section here requires adjustment before finalization. Ensure alignment with the projected overlay.
Torque sequence initiated on station 4.
Uniform stress distribution is holding within parameters.
Readings look good across the board. Okay, lift your side higher.
I've got it. Watch the sealant on the left.
Clear. Push it forward slowly.
The load-bearing points here look solid, well within tolerance.
Agreed. Process A is holding up perfectly.
The robotic arm carefully routes the high-specification wiring harnesses, guided by internal clips.
Check the actuator attachment against the schematic. Looks good. All tolerances are within spec.
And the jettison mechanism torque?
Secure at 35.
The Su-35 undergoes aerodynamic smoothing as a specialized robotic applicator applies high-grade.
Visual inspection clear. Sign-off complete. Prepare for transfer to Process B. Alignment on the longitudinal axis is confirmed.
Cross-check confirms symmetry. We are within tolerance.
Flow rate stabilizing at 98%.
Confirmed. Process A is complete. We can power down the nozzles.
Following the robotic cleaning, engineers meticulously verify the alignment pins, ensuring the high-tolerance connection is ready for the stabilizer integration.
Keep it coming, steady as she goes, right up to the staging line.
Confirmed stable. Stopping at the marker now.
Ready for final descent sequence.
Engaging clamps. Check alignment port side.
Alignment confirmed. Rig is secure.
The Su-35's thrust ecoscopic precision.
Check the alignment on Module 16.
Confirmed, within tolerance. The soldering sequence is proceeding as planned.
Starboard flap cycling initiated. Full range of movement confirmed.
Rudder response is nominal. No friction detected.
Alignment check is nominal. Thrust axis confirmed centered.
Hydraulic lines secured. No leaks detected. Finalizing sign-off on Process B.
We have stabilization.
Confirmed. Laser alignment is within tolerance. Zero deviation. Input signals translating correctly.
Verified on the console. Process B integration is successful.
Ground power sequence initiated. Monitoring bus 1 and 2.
Voltage stable. All systems green for activation.
Alignment is confirmed. Micro-level precision achieved.
Data consistent with Process B parameters. FCC input secured.
Check complete, confirming flawless integration of radar and EW.
Roger that.
Status is green.
As the automated systems secure the radome, the Irbis-E PESA radar is sealed inside. The technician then verifies the closure.
Initiator systems, check. Electrical connection, check. Safety network active.
Deflection at maximum, response is instantaneous.
Confirmed. System stability is nominal. We are go for operational readiness.
Weight secured on pylon 3.
Interface check complete. Status reads live.
Confirming continuity on Station 5.
Process B validation successful. 0 deviation.
Confirmed.
Ground, we are clear on the starboard side, confirming all pins accounted for.
Copy. Team 1, proceed with engine start checks.
The engine start sequence is complete. All parameters are in the green. Fly-by-wire system check, confirmed. The aircraft is live.
Braking achieved, decelerating rapidly.
RTO confirmed. Ground crew, move in and check temperatures immediately.
Roger, moving to the main gear now.
Data download complete on port 2.
Confirming nozzle articulation is within tolerance.
The TVC response was flawless. Absolutely pinpoint control through the entire envelope.
Excellent. Exactly what we wanted to see on the fly-by-wire.
The Irbis-E radar system exceeds the specified detection range, General.
And the thrust vectoring control. How are the maintenance cycles holding up?